Data visualizations. Today I'm going to be going through and ranking 40-something of them on a tier list. All right, now we are on to the variants. And now, since this is the variants, it only felt right for the drink to be the original variant of the old-fashioned cocktail. And this is the improved whiskey cocktail. So the improved whiskey cocktail, I want to say it dates back to like early 1900s. And they're basically trying to take this old-fashioned, which had been created in the US, and incorporate some of the new spirits and liqueurs that were starting to come over from Europe at the time. So we have an absinthe rinsed glass here. So this has a very, very small amount of absinthe in it, and it is what our drink is going to be going into. But we are going to actually be building this one in our mixing glass, beginning once again with 2 ounces of rye, then a 1/4 ounce of simple syrup. And for this one, we are doing just a straight up simple syrup because we really want just that clean sweetness. We don't want to be adding any new flavors in there. And then our other addition to this cocktail, a 1/4 ounce of Maraschino Liqueur. And then we are still doing 2 dashes of Angostura Bitters. All right, so we're gonna give this a good stir to chill and dilute. All right, then I'm gonna strain that into our rocks glass. And there you go, this is the improved whiskey cocktail. And unlike the old-fashioned, which I have had many, many a times before, this is actually my first time trying the improved whiskey cocktail, so let's see if it really is better. Whoa, okay, wow. That is an improvement. It is a different drink. If I walked into a bar and asked for an old-fashioned and I got given this, I do think I would be a little bit upset. I wouldn't be very upset though. It's far brighter and lighter than your classic old-fashioned. Adding in that very tiny bit of maraschino liqueur, sort of splitting the sweetness between the syrup and the liqueur, makes the drink overall slightly less sweet, but then it also adds in this very faint, barely perceptible fruity note to the drink. And so I think that, combined with the sort of anise brightness that absinthe is bringing, you know, very, very light, the main flavor notes of the drink are still very much the spirit, but this one, it's far brighter, it's less sweet, it's a lot more interesting. All right, so this is a very successful variant of the old-fashioned, and let us now get into the variants of our basic visualizations, beginning with the variants of the histogram. The very first one of which is the density chart. Now, the density chart is technically very similar to the histogram in terms of its shortcomings, where the histogram sort of falls short with bin widths being very, able to be manipulated. The density plot equivalent is the kernel. So the actual function that you're using to do the smoothing. By the way, it should be up right now. A density plot is basically a histogram that's been smoothed out. So instead of having very distinct bars that sort of, jump at discrete intervals, it's a smooth, continuous function sort of covering the entire space. So you have to choose some function to do that smoothing, and you can manipulate that to kind of change the shape of the data, but it prevents a lot of the sort of most egregious shortcomings of the histogram, right? Because it's a hard cutoff in the histogram, changing the bin width even a very small amount can kind of fundamentally reshape what that distribution looks like. Whereas with a density plot, changing the kernel is going to change things slightly, but you don't have that same level of like, oh, it was, symmetrical before and now it's asymmetrical. It's like, no, it was smoothed in this way before and now it's slightly smoothed in a different way. If you're really looking to make precise statements about the distribution, the density plot isn't going to be for you, but that's sort of its whole point. Like, right, your histogram is there to get a feel for what the data distribution is. The density plot does that, but better. It should not be used for actual, hard quantitative cutoffs of the distribution. There is a visualization that does that we'll get to later on. But yeah, in my opinion, in terms of what it does, it is absolutely your best bet for it. And so it is S tier. On to the next one, the dot plot. The dot plot is just a worse histogram. Instead of having bars, it's just dots showing the count of observation. Like, I guess it's technically maybe a little bit more flexible than histograms because you're sort of plotting individual observations instead of lumping them together into bars. but this was a plot that was a product of its technology, right? This is a plot that really was big back when you had to manually, physically draw out each of your observations on paper. And then, if you were lucky, photocopy that paper. If you were unlucky, copy it by hand every time you wanted someone else to see your data viz. In the modern era, this is a B tier plot because it's not doing anything wrong per se. It's just not better than a histogram in any meaningful way. So that is the histogram variants done, and that brings us on to the scatterplot variants. And in the scatterplot variants, we are starting off with our very first F tier visualization, and that is the 3D scatterplot. Okay, the 3D scatterplot only exists because some MBA student somewhere had to visualize 3 different dimensions of their data, and Excel just recommended this plot to them as the default, okay? It is basically impossible to take any sort of meaning out of these plots unless they're interactive, and even then it's kind of difficult, right? You really need to be able to rotate these plots in order to get a sense of where these points are actually falling in 3D space, because despite the plot being 3D, it's still being presented to you on a 2D screen, or God forbid, on a 2D piece of paper. And this is one of those plots where if it was your best option for visualizing 3 quantitative dimensions, right? Like if you truly had no other recourse for showing this amount of data, then fine, right? Maybe it's a D tier, maybe it's a C tier. But the thing that makes the 3D scatterplot so bad is that there are so many better ways of visualizing 3 quantitative dimensions. You have so many better options. There's truly no excuse for using one of these besides I just didn't care that much, and Excel recommended it to me as the visualization of choice. So 3D scatterplot is going in F tier. Now the next scatterplot variant is a relative of the 3D scatterplot, I would say, but I am far more forgiving to it, and that is the surface plot. Now on the surface, pardon the pun, it shares many of the same issues as the 3D scatterplot, right? You have a 3D visualization, so when you're viewing it in 2-dimensional space, it's really difficult to see what's actually going on in the data. And then, especially for the surface plot, it actually does add another negative to it, which is because you have a continuous opaque surface, you're actually excluding some of the data, right? Because you have a fixed vantage point and you can't see beyond it because of that solid surface. However, I'm willing to cut the surface plot some slack, and maybe unfairly, but it's due to the kinds of data that a surface plot is typically going to visualize. A 3D scatter plot is typically being used to visualize an actual collected data set where we have gathered some sort of data and we are now visualizing it in a 3D plot. The surface plot is almost always used to show some sort of mathematical detail, right? It's some sort of 3-dimensional function that you're plotting in this plot. Almost all of the times when you're using a surface plot, you're not using it to show actual data and the detail and the granularity contained within that. You're using it to show this sort of general mathematical, function. And if you're missing, specific parts of that function, that's fine because the general gist of it is still coming across in this visualization. So as a result, the surface plot in my book gets a C tier. I think it's one of those ones, it's a really good example of where the use case of a data visualization can dramatically change how good or bad it is, at least in my books. Next up, we have a better alternative to the 3D scatter plot, and that is the bubble plot. So the bubble plot, instead of plotting things in 3 dimensions where you can't see anything, you plot it X, Y, and then whatever that third dimension is, you scale the size of each of your scatter plot points based on the value of that third dimension. So something that's very big bubble. If it's small, small bubble. It works relatively well as long as you have enough separation between your points to make it clear that there's no overlap, or if you are very careful about your alpha levels, so you're very careful about making sure that, points aren't covering up other points. That's sort of the biggest shortcoming of this one. I could see the case for this being a B tier, but in my opinion, it's stuck at C because you just have objectively better options, all right? Use a fucking color bar. You don't need to scale the size of the bubbles. Just use a color bar. It takes care of all of your problems, okay? Next up in the Scatterplot variants, we have the contour plot. Now, the contour plot is basically like, what if we took a surface plot and just kind of, squished it down into 2 dimensions and tried to make it flat so that we didn't have all of those 3D issues. This is one of those plots where there are a few examples where I've seen it done really well, but 90% of the time, it is just absolutely incomprehensible to anybody who doesn't have prior knowledge of what they're looking at. It's not F tier in my books because there are legitimate reasons why you would want to use this visualization, but they're so rare and it's so difficult to pull off that, in my opinion, this one is pretty hard stuck in D tier. Okay, I'm looking at the next couple of charts up and I'm getting whiplash because it is going good to bad, or bad to good to bad so quickly. Next up is the variance of the bar chart, beginning with the horizontal bar chart. S tier, easy, okay? You took the bar chart, you fixed everything wrong with it, right? Having it vertical meant that you have to either have your labels horizontal on the x-axis, which really limits the amount of space you have to work with, or you do them vertical, at which point you have to, crick your neck like this to try to read what the actual labels are, or you do it 45 degrees where you kind of get the worst of both worlds. Horizontal bar chart fixes all of that. Just rotate that bitch 90 degrees. You can have your labels nice and easy to read. They're still rectangles, so the human brain is still very good at, objectively evaluating the size of those different proportions. You can still kind of manipulate the data if you really wanted to by changing your x-axis limits, right? You see this a lot in like news broadcasts where if there's a really small, overall change, but they want to make it seem like a big deal, then they'll pull the x-axis all the way in. The sizes of the bars are very different, even though if you actually went all the way to 0, it's barely any change. But basically every plot that I talk about is vulnerable to that sort of manipulation in some degree. So yeah, so in my opinion, this is an easy S tier. This is sort of like the improved whiskey cocktail, where it's like, what if we just took this one, added a few tweaks to sort of, fix it up a little bit, made it better. And then we go from the horizontal bar chart, which is beautiful, simplicity, elegance, no notes, to the radial bar chart. Who fucking hurt you? Who designed this shit? You've taken a perfectly good bar chart and you fucked it up is what you've done. There is literally, in my opinion, no fucking justification for this, okay? Either you're limited in space, in which case just shrink down your bar chart, or God forbid, use a donut chart at that point, or just stretch it out into a normal horizontal bar chart. I don't understand why it has to do a fucking loop-de-loop before you get to actually evaluate the lengths of your bars. Again, this is another plot where I have no option but to assume that it is an active act of malice against me specifically, and so it is going in F tier with the rest of the failures. Okay, so after those two extremes, we are now on the stacked bar chart. And the stacked bar chart was a tricky one because it's one of those ones where there's nothing really wrong with it, but it's also not doing anything particularly well. If you're interested in the differences of, the proportions of each of the stacked segments in this bar chart, you should use a 100% stacked one because that way everything's sort of even and you can evaluate the proportions better. If you're interested in absolute differences, then you should use a grouped bar chart. So you've got them sitting next to each other so that you can, evaluate the size of the rectangles against each other better, as opposed to having them sort of stacked where the order of the stacking can create different visual implications, right? It can be hard to evaluate sizes against each other when they're sort of stacked unevenly. And then this one, it just kind of muddies the two of them. Maybe there's a use case where this does sort of give you the best of both worlds, but in most cases, you're better off just picking one or the other. And so as a result, this is going in C tier. There's nothing really wrong with it, but there's also just nothing particularly good. There's better options out there. All right, next up is the grouped bar chart. This is really good when you've got multiple, groups that you're looking to compare across a series of qualitative, sort of checkpoints. I think this is one of those charts that suffers from redundancies, right? sort of takes up a lot of ink on the page often. And in a lot of situations, I see it being misused. I see situations where really this should be a multi-line chart because they are just sort of tracking something over time as opposed to a grouped bar chart. But that really kind of comes down to user error. That's not really an issue of the actual visualization itself. And the actual, grouped bar chart, for what it's good at, it is quite good at that, and there's not really a better option for it, in my opinion. But all of that extra baggage kind of drags it down a little bit. And so as a result, A tier felt like a fair tier for the grouped bar chart. That feels sort of a reasonable splitting of the difference there. In a very similar boat, again, building off the previous sort of rant, is the 100% stacked bar chart. So this is sort of a purely proportional bar chart. This is what you should use instead of a pie chart. If you only had a single slice, maybe there's better options, but certainly, for sort of proportions changing over time, this should be your go-to. There are technically better ways of, visualizing the data, but that requires a lot of data wrangling. This is very much, in 99% of circumstances, going to be your best option and certainly your easiest option for visualizing that sort of thing. And so as a result, in my opinion, that is another A tier visualization. Next up, so when I said 40 plus, the actual tier list maker that I'm using has 50 images, but I've grouped some of them together because a lot of these plots are really quite similar, and the differences between them are just, names that people have chosen for them, or they're very minor technical differences that don't really make sense to actually treat as different plots. So this is our first grouped one, and it is the Mosaic / Marimekko / Spine plot chart. The general gist with all of these is that they are sort of a solid block of color divided up into different strips, and then those strips, each represent a different group and changes over time as the proportion of that group changes. It's kind of a, 100% stacked bar chart, but where the different intervals as it progresses are not uniform, right? You can have some that are much longer, some that are much shorter. In most of these cases, what I would actually recommend doing is just using a grouped bar chart, but changing the y-axis from absolute value to a proportion. I think in most cases that would really accomplish what these visuals are trying to do, and it would do it in a cleaner and more concise way. But honestly, I do just have to hand it to these. The aesthetic strength of these plots is very strong. Having a nice solid rectangle, even though it takes up a lot of ink on the page, there is a real aesthetic value to being able to have a solid block and not have this sort of, rise and fall of the actual data just visually. And so as a result, these are going in B tier. You got better options, but I certainly wouldn't, turn my nose up at it. Now, these last two bar chart variants actually really surprised me because I thought I was going to dislike them when I just did an initial skim of, what types were up. But as I sort of dug into them a little bit more, I started to really fall in love with them and really like them. So the first one up is the lollipop chart. The lollipop chart is basically just a reskin of a bar chart, but instead of bars, they are now sticks with a little circle up at the top. And so this really, to me, just sort of takes the bar chart formula with all of its benefits and, drawbacks, and just kind of, tightens it up a little bit, sort of in that very Tukey vein of looking to reduce the amount of ink on a page, right? Looking to make everything sort of cleaner and tighter. Shrinking it down from a bar to just this lollipop really does free up a lot of the visual space on a page, and it makes it far easier for when you have a truly kind of crazy number of different qualitative categories that you have to plot, right? This is really good when you have to plot like countries, where if you had bars, it would really kind of fill up the visual space and become quite cluttered. Whereas with a lollipop chart, you have a lot more white space on the page, and it's a lot easier to kind of pick out individual countries. Again, I think these should almost always be rotated 90 degrees to be horizontal instead of vertical, but I'm not factoring that into this ranking, just sort of going off the strength of the lollipop alone. This is an A tier visualization. And then the final bar chart variant is the dumbbell plot. And this, in my opinion, might actually be the most effective visualization for showing how two different groups vary across, a variety of different topics. You've got one color of the sort of dumbbell for one group, the other color of the dumbbell for the other group, and then you've got a line connecting the two, and you repeat that across, however many qualitative categories you have. And it is just super visually intuitive, right? Of, okay, this color group A, this color group B, here's, are they close? Are they far apart? Super easy to understand, super efficient with the text, really no feasible way that I can improve it. Almost all of the examples of dumbbell plots I've seen out in the wild are horizontal, so they're very easy to read as well. Just an S-tier visualization all around, no notes, absolutely love it. Ending the bar charts on a strong note. And then we are beginning the Boxplot variants on a very weak note because we are beginning with the fucking violin plot. AKA the pussy plot.
And pussy too.
Angela Collier said it better than me. Go watch her video. It's really good. Please watch this first before watching that one, but watch that after. It's very good. She knows what she's talking about. Thankfully, next up in the Boxplot variants, we have the box-in plot, which I did have to look up because I actually hadn't encountered it at all prior to starting this video. And it's kind of like, what if the violin plot didn't fucking suck? It's not quite S tier because it's kind of in that awkward middle ground where there's too much distributional detail for multiple distributions. Basically, the idea is, what if we took the box plot and then sort of, instead of just had it be a singular box representing these quartiles, had it sort of be multiple different boxes so that we could, get extra distributional shape in there. It's a little bit too much information for when you're comparing multiple distributions against each other, and it's not quite enough information for if you're just interested in a single distribution. But overall, I do actually really like it, and I do think there is a real niche for this type of plot, and so that's why I think it's an A. I think it is the best option we have for that kind of middle ground, but I'm just not entirely sold on it yet. I'm certainly not sold enough to put it in S tier. And then the last box plot variant, we have the strip plot, which is basically, what if a scatter plot told me nothing? What if we took the box plot and made it worse by basically every metric? I understand where this plot is coming from, which is why it's spared from being F tier, but still, this is not good. This is D tier. It's easy. It's honestly an act of kindness that it's not an F tier. Okay, on to the pie chart variants. And up first, we have the donut chart, which is good, right? We took the pie chart and we improved it. We cut out the center bit. But have you considered bars? B tier. Then the other pie chart variant we have is the sunburst chart, which is basically a donut chart where if you have hierarchical data, those, initial sort of higher level rings are then separated out into the more detailed, subcomponents. These do work really well. It's kind of a really specific use case. And again, I feel like there are better options for it. It's a specific use case, and even then it's kind of hit or miss. I've seen a lot where it's just like, this should just be multiple visualizations, or you can do sort of like a blowout section of a bar chart. It's a good 80% solution, but there are way better options out there. And so in my opinion, this is sort of the truest B tier visual that we've had so far. All right, line chart variants now, the last of the variants. First up is the multi-line chart, which is probably the most common chart that you've seen. I don't have, data to back up that claim, but I feel like the multi-line chart is certainly the most prevalent. It's incredibly simple, but also, very versatile, used for a lot of different things. It's subject to all the sort of same, manipulations as your standard line plot, but now you've got a lot more lines, so you can plot, various different things and sort of compare how different groups have been changing over time. This can work really well when employed correctly, in the right hands, but it can also just turn into absolute spaghettification if you add in too many groups. God knows I've seen that happen before, and it just becomes completely fucking incomprehensible. But just judging this chart on its own merits, I would say the multi-line chart is easily an A tier. Next up is the area chart, which is basically just a multi-line chart, but where you've given a toddler a crayon and told them to go wild, coloring in everything. There are historical examples of this chart being very effective and being very nice, but I'd say in our modern age, it falls into that solidly fine region. There's not really a need to shade in all of that area. Often what you end up doing is just obscuring, whatever lines are below the shaded area. And you're also actually feeding into some cognitive biases by making it area instead of making it just a line. There are issues with it, but I don't think any of the issues are really severe enough to bump it down from B tier. Sort of a similar thing for the stacked area chart. This is basically just, it has all of the issues of the stacked area chart, but now you've made it continuous, right? Instead of being sort of discrete jumps, it is now a continuous flow of problems. The problems aren't bad enough to warrant inclusion in D tier, but it doesn't do anything good to bump it out of C tier. Oh boy. Okay, and then we have the stream graph. So the stream graph is basically like, what if we took all of the worst parts of the violin plot, already an F tier visualization, and the stacked area chart, and combined them into one? I have not seen a single example of a stream chart being able to effectively, convey its message, and I do not anticipate being proven wrong on that fact, all right? F tier, go straight to jail. Next up is the step line chart. And I think this might be one of my more controversial takes of this series, if anybody else has strong opinions on this like I do. I actually really like the step line chart. If you have some process that moves in discrete time steps, this is the best way to convey that process over time. You're not doing any sort of messy interpolation between those discrete time steps. You're just saying, we measured it at this point and it was here, and then the next point we measured it was here, and there is a straight line jumping up between those 2 points. It's not flashy, it is a very simple visualization, but I think it is very honest and very accurate in what it is trying to convey. And so, yeah, as a result, I actually really like it. S tier. And then the final variant is the waterfall chart. And as much as I hate to give credit to consultants, I think McKinsey & Co. kind of snapped when they made this one. It's essentially a step line chart, but with a qualitative x-axis instead of a quantitative one, right? So instead of a very sort of, continuous time-based x-axis, you have it more broken down by sort of discrete checkpoints. And then it's basically a cross between a bar chart and a stepped line chart that just very cleanly and concisely conveys what it's trying to get across, right? At this point, you gained X units of a thing, so here's the bar that goes up. And then at Y moment, you lost, Z units of a thing, and so the bar goes down. And so you can sort of look at this overall visual and be like, okay, gain, loss, gain, loss. Very intuitive, very easy to understand, very clean. I really like it. I think, I think this is a really good one. I think this is S tier.